Interesting weekend for me. We drove over to Oklahoma to a family wedding. So my niece's daughter, so I guess it'd be my great niece, got married. I don't have that. I guess that's it. It's my sister's granddaughter, if that helps. Sister's granddaughter got married. And we were doing the photography. My son-in-law and his wife and my daughter, and I helped, but they were the main ones because he's the video guy. He's got his own production company. He's done wedding photography, so we did a lot of photography there. Him and my daughter, they did most of the ceremony, and I helped take pictures at the reception. And so we that was all of our Saturday. We got up early Saturday, drove over to the wedding, and then drove back Saturday night. So it was a long day. And then yesterday, this head cold flared up. I pretty much stayed in bed all day. We was going to go to a movie, but no one felt like it. We were all beat up from this cold. I think my daughter's the only one that doesn't have the cold, and my grandbaby. But my son-in-law has it. My wife has it. I have it. We're just miserable. But come on in. About got everybody. All right. Well, we're going to get started here. Just because we've only got so much time, and we need to take a look at what this week holds. Programming, looking at our grade screen. Let's go down. Oh, we're ready to start our third module. This will be our last module for the semester. So we're through with the math module. For those of you who did not sign up for the discussion-based assessment, or there's a couple of people that signed up and didn't make it, missed their time, forgot, or whatever. You'll need to come in on one of our other days. This isn't a day Friday, so you'll need to come in Wednesday or Friday during class and say, Mr. Brock, I need to take that discussion assignment. So we'll do that during class periods, because last week I broke out extra time outside of class to accommodate that. I can't do that every week. I've got too many other things I have to get done. So that's a stressful week for me when I have to allocate extra time for that. But that was last week, and I'm not doing that anymore. So now you have to come during class and ask for that. So, and you can come during the whole hour and a half class, because on Wednesday, Thursday, Fridays, those days, all classes are an hour and a half. I don't break it into two groups for those days. But today we're going to look at Turtle Graphics. Turtle Graphics 3.01. We're going to start a little graphics module here. So close the Module 2 folder, open the Module 3. Okay, let's see what kind of graphics is offered. It's kind of basic, but it's kind of fun. So let's have an honest conversation about turtles. Since it calls it turtle graphics. They live to a super old age. I mean, there are turtles that could be like 100, 150 years old. It's amazing. And they could be ninjas sometime. There's just a few of them that have been able to become ninjas. And they take the concept of mobile homes to a whole new level. I mean, they've got it going on. They've made a pretty awesome contribution to the programming world too. So you're going to see how turtles have influenced visual programming. So we're going to be able to explain the role of the Turtle Graphics module, understand how programmers utilize Turtle Graphics for improved productivity, and demonstrate understanding of Turtle Graphics by setting up and moving the turtle. Now, next week, I believe, is our assignment on Turtle Graphics, but you want to pay attention this week. You want to go into the lesson and practice with it this week so that you understand how it works and how the Turtle Graphics kind of function there. You've heard of those apps that map out your exercise? They draw a line that shows the distance and direction that you run or walked or driven, no judgment. These actually work a lot like a set of functions in Python, like Turtle Graphics. The Turtle Graphics module is one of the many modules that Python has in its library of functions. And by using these and other built-in functions, programmers are able to import pre-written code and make use of it and write their own programs. For example, you can use the input function to prompt users to enter information rather than having to write an entire program to gather input. Makes things faster, more efficient. So Turtle Graphics functions let you program visually by moving the cursor across the screen. In other words, you can make an imaginary turtle draw pictures using his imaginary pen. So you tell the turtle, hey, I want you to grab your red pen and make this line for me. So the little turtle crawls across the screen and makes a red line. So let's look for ourselves. Let's look at this Python guided activity. and see how it works. So comment the turtle module. So we have to import the turtle, just like you have to import the math functions. We have to import the turtle. Say, hey, Python, go grab the turtle. I want to do some graphics. Then we define our main function. And then we have to name our turtle. So in this case, we're naming the turtle Tom. Tom equals turtle.turtle. That's how we name it. Tom equals turtle.turtle. And so then we told Tom to go forward 50 pixels. That's the little pixels on the screen. And then turn left 90 degrees and go forward another 50 pixels. And that's the end of our function. So let's see what that looks like when we run it. Oh, Turtle Graphics has its own little box over here. The output split. So you have any text or numbers would be printed over here. Graphics has its own screen. And you see what happened. We then told Tom to go forward 50 pixels. So that's the distance of 50 pixels right there. Then we said turn left 90. So that's degrees. Turn left 9 degrees. And then go forward another 50 pixels. So that's the exact same distance. All right, let's go look at the next one here. Import turtle, define main. Hashtag, let's see, run program. Oh, it says Tom is not defined on line 8 because it says Tom move forward. See, the problem is they put a hashtag, so they made that a comment. They didn't name their turtle. You have to take off the little comment, and then when you run it, now it says turtle's not defined. Well, why is turtle not defined? Because they put a comment up here on import the turtle. We never imported the turtle. So you have to make sure you import the turtle, make sure you name your turtle, and now it runs and it's happy with no errors. Got to use the import. All right, let's go to the third slide. Read the code, try to predict the output, run. Okay, now let's see what's happening. Importing turtle, that's good. Naming turtle Tom. Told him to move forward. Oh, we told him to move forward 50. Turn left, move forward 50. Turn left negative 85 degrees. That should mean turn right, right? You could say turn right 85 degrees, or we can say turn left negative 85 degrees. Either way. Go forward 35. Turn left 110 degrees. Go forward 70. Turn left negative 20 degrees to go forward 20. Let's see what that looks like. And that's the end of the program. Run. 50, 50. Whoops. Wow, it went up off the screen. Let's move it. There we go. So the turtle's path getting longer with forward and left commands. It's just using lefts and forward. You can do negative left. So that was the negative 85 degrees. And it went forward 35. And then we left 110 degrees. So that turned 110 degrees. And then went 70. And then went a little bit, 20 degrees off, and went forward 20. So kind of building some shapes there. Now let's look at this one. Explore the turtle by adding forward and left commands to the program. Okay, so they gave us the exact same program, and now we get to add some. So let's turn Tom left again. Tom.left. And let's go left like 135 degrees. And then bring Tom forward 150. Let's see what that does. Oh, brought him way back down. Tom.left. What is this? Maybe 150 degrees to try to get back to where we started. And then Tom.forward. I'm going to guess 55. Oh, no, that was too far. Not 150. Maybe 95. Oh, not 950. Let's try that. That little turtle boogies, though. Oh, that was close. 105. That's pretty close back to where we started. So you can just play with it. We could also make some right turns. Tom.right. 90. Oh, let's say 170. Make it go almost back where it was. Let's say 160. And then Tom.forward. 100. Well, not 100. Dot. Parentheses 100. So I would suggest you go here and play this. Go to page 2, play with this and see what you can make the turtle do. See that you can do right turns. That was a right turn. But you could play with the turtle on page 2 before we have to write a program next week. All right, so here is a steps to follow when you use the turtle graphics. Import turtle. Define main. Here they named the turtle Raphael. Yeah, I know a turtle named Raphael. Oh, and they move forward to 50, left 90, forward 50. So you use the functions. You have to import it, name it, and then use the functions to tell it which direction to go. Now, turtle graphic models has a lot of useful functions for drawing, like forward, backward, left, right. Notice the forward function requires an integer parameter that indicates how many pixels it should move forward. And there's tons more you want to know for complex visual graphics. So if we go to this Python API that has the turtle graphics module, we can click on right here and see, well, there's the turtle. Import the turtle, name him Terry.turtle.turtle. We can do backwards. So we can go backwards. Begin fill. Oh, so it can fill up the shape. Begin fill. As you make a shape, it'll color it in. So it kind of shows that. You make a circle of radius, whatever. Circle of radius and arc degrees. Change the arc. Color, we can change the color. Look, Terry.color.red. End fill. Look there, they made a circle and filled it yellow. So, oh, gold. See, Terry color.gold, Terry begin fill, Terry circle 50, Terry end fill. Forward, we did that one. Hide turtle. Stop showing itself. Left, pin down, pin size. You can make a bigger pin. See the pin size change right there? Pin down or pin up. So the pin down function places the pin down in the drawing position. So the trail is drawn until the pin's picked up again. So if you want to make the pin up, move the turtle and put the pin back down so it doesn't draw a line when it moves, you can do that. And then there's right. You can set a heading to an angle. You can say go at 22.5 degrees. You can set a position, a starting position. All kinds of options. Shape value. Interesting. The shape turtle. Terry.shape.turtle. Show turtle. Speed. You can say how fast your turtle moves. Stamp. It leaves a little stamp of the thing there where it goes. So there's all kinds of stuff you can play with. And that's in the Python API that gives you all the commands you can use with the turtle graphics. All right, let's look at page 4 here. What can turtles do? Can they draw more lines? You bet. Add more instructions for your turtle by using the functions for the turtle graphics module that we just looked at. So look over here, they're growing all kinds of weird stuff. So here's a programming spotlight. Seymour Papert. Most likely build an army of robot turtles. It says he's still alive. I'm not sure. He'd be 96 now, I guess. He's the co-inventor of the Logo programming language. Was also an early innovator of artificial intelligence. He set the groundwork for what we now know as turtle graphics, creating the Logo turtle, a tiny robot turtle that taught children how to program through problem solving. So I just wonder if Seymour is still alive. Let's see. No, he did die in 2016. He's not alive anymore. He was from South Africa, by the way. But he lived in Maine when he died. All right, let's practice using this. Here's another activity. So page 2 and page 4 both have turtle graphics for you to play with. Shapes with the turtle. Import turtle, define main. This time we named our turtle Tina. And we told Tina, hey, go get the red pin, Tina. So Tina went and got the red pin. Told her to go forward 100 pixels and then turn left. Go forward another 100 pixels, turn left. Go forward another 100 pixels and then turn left. So let's see. There's Tina. There you go. And we can complete the square if we want to tell Tina to go forward another 100. There you go. Let's add that. There you go. So there's Tina with her red square. And we can change the colors. Let's say, go get the blue pen, Tina. You should make it blue. Or go get the green pen. You can type all kinds of colors. Oh, don't hit the enter. Don't hit the enter. There we go. Green. Let's see. Let's get a little creative, like crimson. Yeah, it kind of knows what a crimson is. What's like mauve? What's mauve? Oh, it just did black. I don't think it knows mauve because I don't think mauve is black. But so if you choose a color it doesn't know, you may just get a black turtle. How about a brown? Oh, I keep hitting enter. There we go. All right, let's look at the slide 2. Read the code, predict the output, run it, add the code to complete the second triangle. Oh, so this is doing a triangle. Tori's our turtle. We're going to grab our purple pen. And Trey. So we can name more than one turtle. We've got Tori the turtle and Trey the turtle. So Tori's got a purple pen. Trey's got a blue pen. And we set the size equal to 100. We just said we're going to make them all 100. So we told it just go forward, standard size, turn left, standard size, turn left. And then Trey, we said go backwards and turn right. So let's run this. So there's Tori turning left, and there's Trey. So he needs to complete his triangle by going Trey dot right 120. And Trey's moving backwards here. So backward size, same size. All right, let's run that and see. Tori made Tori's circle, and Trey made his circle. There you go. Completed the 2 triangles, 2 different colors, 2 different turtles moving at the same time. Let's see if we can do this. What was that one command? Tori.shape turtle? Was that how that worked? Let me try that one. It didn't do anything. That must not have been the right command. What was that turtle shape command? I want to look at that, see what we can do with that. Turtle graphics, num steps, fill. Oh, we should try the fill. Terry begin fill. Oh, so let's put that in our instead of the shape. We'll do this, and we got to change it to Tori because our turtle's named Tori. Tori begin fill. Let's run that and see what that does. Oh, it didn't fill it. We did something wrong with that. Let's look at this command again. Color function functions. The begin fills indicate starting point of the shape to fill with color. And then end. Maybe we have to have the end fill before it works. Let's put the end fill down here. Tori dot end fill. Oh, okay, let's see if that works. See, we have to start the fill and end the fill. We got to tell it with the end. And so we filled up that one by using the begin fill command, and then you're going to have the end fill command. Let's go back again. Circle radius number of degrees, circle color C, end fill, forward number of steps, hide turtle, left angle, pin down, pin size, pin up, right angle, set heading, set position. Oh, here it is. Let's see. Oh, I got to put turtle in quotes. Okay, so Tori.shape.turtle. Let's see what that does. Oh, see, now Tori actually looks like a turtle. I changed Tori to be the shape of a turtle. So we should play with that. Is there other shapes you can be? Can it be a car? No. Turtle is the only thing you can do. You can make it just an arrow, or you can make it a turtle. But you can actually make it a turtle running around on your screen drawing these things. All right, let's look at slide 3. Okay, so we got Tia the turtle, who's going to grab a blue pen, and Ted the turtle, going to grab an orange pen, and size equals 20. Tia's going forward 20, turning left 72 degrees, forward 20, left 120 degrees, and now the size is going to be +7. Go forward that, turn left 72, And then Ted's going forward the size and left 120. And now, so it keeps adding 7 to the size and repeating, adding 7 to the size and repeating over and over and over again. Oh, look at there. That's interesting looking shapes. Let's do that again. So by increasing the size with each forward command, you get the spiral shape start to happen. So that's pretty cool, just by setting it a size and then just changing it every time. Making the size a little longer, a little longer, a little longer. Now, and it's different, the angle. See, T is turning 72 degrees, so it's kind of making this type of pentagon shape. Ted's going 120 degrees, so it's kind of making a triangle shape, but each side of the triangle is getting longer and longer, so it doesn't connect with the previous side. So you can make some pretty cool designs. Let's look at this one. Terry the turtle is going to get a green pin, and we've got a size of 35, and that's it. I guess they're leaving it up to us. It says make an octagon or an outline of a house or whatever shape we want to do, refer to previous slide. So this is where you come in and practice. Let's say, Terry, we haven't done circle size. Let's see what that does. There you go. Size of 35. And then we can say size equals size plus 20. And then have Terry dot color. Let's get a different one now. Let's do red. And Terry dot circle size again, because we've changed the size. Oh, red is not, oh, I didn't put it in quotes. You got to put it in quotes. Now I like it. Let's try it again. There we go. So we made a size 35 green circle, and then we added 20 and made a red circle. So now let's do size equal size minus 10 and change it to blue, and then have Terry make another circle size green, red, and then a blue one right in the middle of those two. So you can keep making different size circles and kind of make like a tunnel like effect there, right there. And then you could put it all in a box. Let's see. Let's go down and see if we can make like a triangle around it now. So we can tell it to go Terry dot color dot let's go gold, and then we'll say Terry forward dot 100. Oh, parentheses 100. Terry left 90 degrees. Terry dot forward 100 again. Actually, I can just copy those lines a couple of times here. Gotta take out the space. And I wonder if that's going to be too big. 100. I need to probably go half the distance this time, and then go a full 100 up, full 100 up, full 100 up, and then half the distance again. So let's see, if we go forward 100 and left, that's going up, then forward 100, and then it's going right, and then 400, that's going down. And then I need to go Terry dot forward. Let's try 50 and 50 on the first one. Let's see if that looks like we want it to look. We'll try this out. Okay, gonna make our 3 circles first, and then up, not big enough. Oh, then that I didn't turn. I didn't turn again. Terry dot left 90. But we need this to be a little bigger. So let's go 60, 120, 120. I guess this needs to go 120 and this needs to go 60. All right, let's try that. Just got to keep playing with it to get the what you want. 60, 100, there. Okay, that got it. So now we're putting our circles inside of a square. So since I was in the middle, I had to go 60 and then 120, 120, 120, and then 60 back to where I started at. But the best thing to do is just go play with this. Hit this Python API button and look at all the different turtle graphic things and practice with them. Practice with them. You know, the start fill and all that kind of stuff. Begin fill. I wonder what happens if we do the begin fill. Will it cover up the circles? That's the question here. So let's say Terry.begin fill with let's try like gray or something weird like that. And then we'll do an end fill at the bottom. Terry.end fill. Did I do that right? Oh, I did something wrong. Let's go back to the API. What did I do wrong? So I've got to refer to this to see what we got to do with begin fill. Oh, I can't choose the color in there. It's going to do whatever color is set above that. So, okay, so I have to take the color out of that and just say begin fill. Let's see if that's right now. Yep, it covers up everything inside of it. So it doesn't. So if I drew it first, let's move that up to the first. Let's do that. Let's try that. Let's cut that out and put it up here at the top. And then draw the circles. All right. Oh, local verb. Oh, did I put it before I defined my turtle? Oh, yeah, I moved it before my turtle. I got to define my turtle first. There we go. Terry equal turtle. All right, let's try it now. So I'm going to make my square and then draw the circles inside. Ah, that's better. You just got to keep playing with it till you get the look of what. Get creative. Play with your artistic skills there and see what works best. So draw an outline of a house, an octagon, whatever shape. I made a square with 3 circles in it, getting smaller and smaller and smaller, it looks like, as they go inside there. And I could continue that pattern. So you're just limited by your imagination and the tools available with the turtle graphics here. But you can do a lot with that. You can play around different shapes because you can turn things at an angle. Remember, I can say turn 10 degrees. So then I can draw any kind of shape. I just have to figure out how many degrees I want everything to turn. And I just keep running it and changing the numbers until it looks like what I want it to look like. And you can fill shapes and you can change colors. You can have it show the turtle or not show the turtle. All kinds of good stuff like that. All right, that is the end of the lesson. Let's look at the assignment that goes with it. Remember, we're going to be writing a program doing this, so you want to go in and practice right now before you have to figure it out later. Let's see. Python has a built-in library of functions, including the turtle graphics module. Does it? Let's an example of a built-in function. Mastin's creating a program to display users' daily stock statistics. Going to show a graph. Oh, that'd be cool. You can make a graph with that. Sure. Let's see. Got to have which one of these? Would it be faster to write new code as opposed to built-in ones? All right. So pretty simple 5 questions this week. So that shouldn't be a big problem. Next week, we'll explore more into this. We're going to look at for loops next week. For loops are going to be very, very useful in graphics. Going to be great in graphics. So get in there and practice this week. You got simple 5-question quiz. Of course, if you're behind on programs, be sure and get that caught up too. But Turtle Graphics is going to be where we're finished the semester to learn this. And once you learn loops next week, that'll help your graphics go even better because we could take some shortcuts and draw a bunch of stuff quicker. But yeah, learn how the turtles work. Have fun with the turtles. Name your turtle. Give your turtle whatever name and all that kind of fun stuff. So, all right, guys, that's all I got for you this week. Turtle graphics. So we're going to have some fun, some artistic stuff. I've seen some great programs over the years of different kinds of artistic things that people spend some time on. So looking forward to that again this year. And we will catch you guys Wednesday or Friday if you need to be here. If you need help with a program that you're still stuck on, come see me. Otherwise, I'll see you next week. Thanksgiving's coming.